Inverses are an interesting topic in math, and they're really an important topic in math because they have such a good use. Let me show you the use first. Let's say this is you, and you have a credit card number, and you're going to buy something online. Let's say your credit card number is 123. And you're going to buy something online that's coming from this store over here, and they're going to send it to you. So you gotta send them some money. Well, what happens is you put your credit card in a computer, and it sends that number to a satellite, and it bounces over to that store or to that bank. But while that number is in the air, that's just like a TV or a radio wave, a TV wave. It's some kind of a wave. Some other person for $100 can buy a piece of software on their laptop and just sit and read waves that are in the sky, and they can grab your credit card number 123 and steal it, and then they can buy stuff from that store on your credit card number. So there's a real need that when you put your credit card number into space, that it's scrambled. So 123 is more like 974. So that if it gets stolen, 974 is the wrong number and it won't work. So we need to have a formula that takes 123 and turns it into 974. But then when it gets to the store, 974, they have to be able to turn it back to 123 so that you can buy your stuff. Okay, so we have a formula that will scramble, and then we have a formula that will unscramble. And the unscramble is the inverse formula. The inverse will undo the scramble. Okay, so it looks like something like this. Let's say we have a scramble formula. F of x is 3x plus 2. Okay, what that means is if you put in a 5, okay, that means we're going to be 3. Let's say your credit card number is 5. So that's going to be 3 times 5 plus 2. So it's going to come out as a 17. So if your number is a 5, it's going to hang around in space as a 17. But when it gets back, there has to be some way to get 17 back to what it was. We have to be able to descramble it. Okay, that's called an inverse. And the notation is like this. It's f negative 1 of x. That means inverse. And our task is to find it. Well, look what we did. We tripled our credit card number and we added 2. So maybe it's just the other way around. Maybe we divide it by 3. So maybe the inverse formula is divide by 3 and then subtract 2. That kind of looks like the opposite of that. So what I'm saying is if we put the 17 in there, it should produce 5. Well, as you can see, 17 divided by 3 minus 2 is not 5, so that is not the inverse. I'll show you what it is. The real inverse is, let's see, take your number, subtract 2, then divide by 3. See, if we take our 17 and put in there, it should produce, if it produces 5, that's the inverse. So f inverse of 17, I put the 17 in there. See, that's 15 divided by 3, which gives us the 5 back. So this formula it undoes this formula. Whatever I stick in this formula will get back the original. Let's try it with a different number. I tried it with 5. Maybe I'll try it with 10. F of 10. That would be 30 plus 2. So if my credit card number is 10, it's going to be hidden as a 32. F inverse of 32 then should give me back 10. So if I stick a 32 right there, I get 32 minus 2 over 3, and sure enough, it gives me back the 10. So see, 10 went in the scramble to a 32. 32 went into the descramble and got it back to 10. That's what an inverse does. Okay, well, how do we find an inverse? How did I know that this was the inverse of this one? Okay, well, one of the things that inverses do is if you were to graph it, it's a mirror image. It folds across this line. So for example, if I had a dot at 1, 2, 3, 4, so if one of my dots on the graph is over 4 up 0, you see I'm going to go towards that diagonal line at a right angle and then come out of it the same distance, 1, 2, 3, 4. It puts it at 0, 4. Okay, so inverses always fold on this diagonal. If I have a number at 1, 2, 1, 2, 3, let's say it's right here, 2, -3, that's going to go into that diagonal at a right angle and come out the same amount. It's going to come out right there, and I happen to know it's going to come out at -3, 2. I happen to know that because I know what the rule is. The rule for inverses on any point in a graph is whatever the original point is. See, like here, it was 2, -3. The inverse switches places to yx. That means the inverse of 2, -3 is -3, 2. That will always put it across this diagonal. You exchange the x number for the y number. Well, that's how you find formulas for inverses also. This f of x, so oftentimes it's written f of x equals 3x plus 2. Okay, f of x is like the y. You can think of that as the y. Okay, now we're going to apply the inverse rule. Okay, every place there's an x, we're going to put a y, and every place there's a y, we're going to put an x. So we're just going to put an x where the y was and a y where the x was, and then resolve it for y. So I'm going to move the 2 to the other side and divide off the 3. And there's the new inverse, y equals x minus 2 over 3. Now, to not get them confused, y is typically the original, and then y prime is typically the inverse, or usually it's f of x is the original and f of -1x is the inverse. So those two equations will undo one another. Those two equations will undo one another. So if they want us to find the equation that will undo this, so I'm going to think of this as a y right here. This is y equals all of that. So I just replace it. X equals 3y. And then resolve it for y. So we get another y equals. So I'll move the 3 to the other side and divide off the 3. So our new inverse is x minus 3 over 3. So I'm going to put it in that notation. G inverse is x minus 3 over 3. That's the inverse of that G. Now we can test it. Let's just test it on something. Let's make up something like maybe a 2. G at 2 was 3 times 2 plus 3. See that? I just put the 2 right there. Okay, that's 6 plus, so that's 9. That means if I put 9 in the inverse, G inverse of 9, I should get back 2. That should give me back the original. Okay, so if I stick 9 right there, it's 9 minus 3 over 3, which is 6 over 3, which sure enough is 2. That's a little way to kind of check. Pick any number, get the scramble, put the scramble in, you should get the original number back. So you can always check yourself, and if that doesn't work, then you made some kind of a mistake. Okay, here's this one. Replace the x for the y and the y for the x. Resolve for y. So I'll move the 5 over and divide off the negative. So I'll have y equals negative x plus 5. So there's the inverse. G inverse of x is negative x plus 5. And again, we can test anything. What if I pick g of 1? Okay, that's negative 1 plus 5, so that's 4. That means if I do g inverse of 4, I should get back 1. Well, that's negative 4 plus 5. Sure enough, it's 1. So I plugged in 1, got 4. Plugged in 4, got 1. Now, doing this one little test is not a proof. Here they want us to actually do a proof. They want us to do a mathematical proof. We could always do a test. A test is stick something in, like 1. If I stick a 1 in there, that's 5 halves times 1 minus 5. So that would be minus 10 halves. That's negative. Okay, how about I test a 2 so I don't get fractions? I'll test a 2. That'd be 5 halves times 2. The 2's will cancel out. Okay, let me start over. That'd be 5 halves times 2 minus 5. The 2's will cancel out. 5 minus 5 is 0. That means if I stick a 0 in this one, h of 0, it should give me back the 2. Okay, that's 2 plus 2/5 times 0. Well, sure enough, 2/5 times 0 is 2 plus 0, gives me back the 2. But that's not a proof, that's just a test. That works for 2. A proof wants to know, will it work for anything I stick in there, like 2.1 and 2.2 and 2.9 and 7 and negative 35. So it's impossible to mathematically try all the numbers there are, so we need a way to prove it. Okay, here's the proof. It's got 2 parts. We need to show that f, if you stick in g of x, is x. And, so it's 2 parts. We also have to show if we start with g and stick in f of x, it also equals x. And I'll show you what I mean by that. Okay, let's do this one first. G of x. Oops, it was called h of x in this one, so we got f and h. Okay, h of x is this formula right here. So I have f, and I'm just going to replace the h of x with that. So it's 2 plus 2/5 x. Okay, so that means take this and put it in the f formula. So here's the f formula. So it's 5 halves times something minus 5. Okay, well this is what goes in there. 2 plus 2/5 x. Okay, let's multiply this together. 5 halves times 2 is 5. 5 halves times 2/5. Those 2's will cancel out, the 5's will cancel out. That'll leave me x. And then I still have this minus 5. And sure enough, 5 plus x minus 5 equals x. So that's the first check mark. See, when I took the h formula and I plugged it into the f formula, multiplied it all out, and it ended up just equaling x. The same thing has to happen the other way around. If I take the h formula and stick in the f, which is 5 halves x minus 5. Okay, so h is 2 plus 2/5 times whatever, and this now is the whatever, 5 halves x minus 5. Okay, 2/5 times 5 halves, that's just x. When I multiply 2/5 times 5 over 1, the 5's cancel out, so that becomes minus 2. And out here I still have a plus 2, so 2 plus x minus 2, sure enough, is just x. Now, saying it equals x is not enough. It's this. It's showing the steps that actually matter. So you have to have the work that does that, not just say equals x. And somebody's got to be able to follow it. You got to put the first formula in the second formula and do the algebra. Put the first formula in the second formula and do the algebra. It either does or does not equal x. Since both of those equal x, yes, those are inverses of one another. No matter what you put here for an answer, if you take the answer and put here, it'll get you back the original number. Let's try that again with number 5. Okay, I need f of g of x, and I'm wondering if that equals x. Sorry, I have f of g of x, and I wonder if that equals x. Okay, here's the g of x. That's this one right here, negative 3x plus 12 over 2. Okay, so it wants me to put all of this into f. Okay, f is negative 4/3 times whatever plus 4. And all of this goes in there. So this goes in there as a negative 3x plus 12 over 2. Okay, I'm going to multiply it together. So I need 4/3 times all. So 4 times 3 is 12. So I need 4/3 times 3/2. Those go away. The 2 will reduce that down to a 2. And negative is a positive. So 4/3 times 3/2 is 2x. Now I need 4/3 times 12 halves. 4/3 times 12 halves. That reduces to a 4. That reduces to a 2. It looks like it equals 8. So a negative times a positive is going to be minus 8. Okay, that is not going to equal x, so this answer already is no. You don't have to, since they both have to be true, if one of them never makes it to x, then these are not inverses. This does not undo this. All right, 7 and 8 are just more practice. 6, 7, 8, and 9 are more practice of that. So they want us to find the inverse. So here's what we have. Y equals 4 over x minus 3. I just wish they would make that an x instead of an n. Seems dumb. Because now you exchange x for y. Now the hardest part sometimes is solving it back for y. So I'm going to go ahead and add the 3 to the other side. So I have x plus 3 equals 4 over y. Now when y is in the denominator, you have two choices. You could just cross multiply. Okay, so if I cross multiply, I have 4 equals y times x plus 3. And I'm trying to solve it for y, so I'll divide both sides by x plus 3. So those will go away, and here's our inverse. Y equals 4 over x plus 3. So we would write that as f. Now in this case it's g. So the inverse is g negative 1 of x equals 4 over x plus 3. That's what we're looking for. Now I said there was two ways, and one of them was cross multiply. The other way to get the y off of there is you could just turn this whole fraction upside down. I could say it's 1 over x plus 3, so I'm just turning this one upside down, equals y over 4. And then cross multiply. That doesn't really help on this one, so I think I'll forget about that. It'll show up again. That was probably the fastest way there already. Now, of course, you could try something, like maybe 4. If I stick a 4 in there, 4 divided by 4 is 1. 1 minus 3 would be negative 2. That means if I stick negative 2 in there, it should give me the 4 back. So I'll stick it right there. It would go right there. Negative 2 plus 3 would be 1, so I have 4 over 1 equals 4, which is what I started with. So it seems like that is the inverse. Number 7, here already is the y, so it's y equals 4 over x minus 1 minus 1. Okay, first you replace x with y. X equals 4 over y minus 1 minus 1. I'm going to move the 1 to the other side, so I have x minus 1 equals 4 over y minus 1. All right, let's cross multiply that, so that's 4 equals x minus 1 times y minus 1. I'm trying to solve for this y. I don't want to multiply all that together yet. I think I'm going to go ahead and divide by this package x minus 1 from both sides. That way that package will go away. And now we have 4 over x minus 1 equals y minus 1. And now I'll just move the 1 to the other side. And I'm going to change the notation while I'm at it. So what I'm saying is if we stick something in this equation and get an answer, we should be able to take the answer and stick it in this equation and get the original number back. Come on. Hi, Betty. Yeah. Oh, that's okay. So let's say we just put in like maybe a 5. Looks like that would be pretty easy. So if I stick a 5 right there, 5 minus 1 is 4, so that makes 4 over 4 is 1 minus 1. That's going to equal 0. What that means is if we put a 0 in this one, it should give us back 5. Well, if I put 0 in there, I have 4 divided by -1. That would be -4 plus 1 equals -3. Okay, something did not work out so well there. Okay, I'm glad I checked this one. Oh, let's see. Was there a mistake someplace? Exchange x for y. So x equals, and then y minus 1. We move the 1. Oh, it's right here. Gosh. This minus 1 should have come over here as a plus 1. So that should have made that an x plus 1. Makes this an x plus 1. Okay, now let's see if we stick 0 in there. If we stick 0 in there, we have 4 plus 1 actually equals 5, which is, so you can make sure you get them all right all the time by taking an example. If one number works, it's likely you got it right. If a number doesn't work, it's positive you have it wrong. Okay, so again, a proof. So we have to be able to take f of g of x and show that it actually equals x. Okay, here's the g of x. -2 over x plus 1 plus 2. That's the g of x. Now I'm going to plug that into f. All of that goes into f. So f is -2 over all of that stuff minus 2 minus 1. So let's put all of that stuff in there. It's -2 over x plus 1 plus 2. Okay, so let's go through the steps and make sure we have it all correct. So there's nothing going on in these parentheses, so this is just a +2 minus a 2. Okay, so I still have the -2 on top, plus 2 minus 2 is gone, so we end up with -2 over x plus 1, and then this minus 1 is still there. So I've got to try to simplify this fraction to see what happens with this fraction. Okay, we did some fraction work a while back. If you have we want a 4-part fraction. So I'm going to make it -2 over 1. Here's the top. Over -2 over x plus 1. Still have that minus 1 out there. Okay, I want to simplify this. There were a couple ways to simplify that. We could flip off the we could get a super common denominator and throw out the denominator, or we could flip the bottom over. I'm going to flip the bottom over. I'm going to go x plus 1 over -2. See, that makes, as a package, those reduce and the -2's reduce. But if I do this in red, I've got to do it in red up here. X plus 1 over -2. Okay. Well, let's see what happens here. So now I've got a -2 up there, reducing a -2 right there. So all of this complicated fraction ends up being x plus 1. And then there's still this minus 1, so the whole thing ends up being x. So sure enough, by taking g and plugging it into f, we did get x. Okay, but that's only half. Okay, the other half is take g and plug in f of x, and it needs to do the same thing. Okay, f of x is right here. It's -2 over x minus 2 minus 1. And that has to go into g. Okay, g is -2 over blank plus 1 plus 2. And now this goes in the blank. So the -2 over x minus 2 minus 1 goes in there. Okay, on the bottom, there's a minus 1 plus 1, so those add up to 0. So now I've got negative 2 over x minus 2 plus 2. Okay, same thing. I would like this 3 stacked up fraction to be a 4 stacked up fraction. So I'm going to make it negative 2 over 1 over negative 2 over x minus 2 and try to simplify this. Okay, I'm going to do the same trick. I like to get the bottom one just to cancel out. So I'm going to multiply the bottom by x minus 2 over negative 2. But whatever you do in red down here, you have to do in red up here. X minus 2 over negative 2, and see what happens. Well, as a package, those reduce. Negative 2 and negative 2 reduce. Negative 2 and negative 2 reduce. And what's left out of all that fraction is this little piece, x minus 2. And then there's still this plus 2. So it's the steps that have that. So when I'm grading these, I'm looking, okay, did you get this? Did you see that the 1s went away? Then did you see that these entire packages went away? And then did you see that the 2s went away? So you have to do them in the right order while you're unwinding those. Okay, let me get some more space for number 9. So if there's something that's difficult about these, it's just doing that algebra. Okay, here's number 9 with some thirds. So what I need is f of g of x. I need to put g of x inside f of x. So g of x is the third root of negative n plus 3. Okay, that should be an f out here. This was g. So f is negative whatever to the third plus 3. And this stuff's what goes in there, the third root of negative n plus 3. Now that negative is important. See, that negative was outside the n to the third, so that the third does not reach that negative. It was only on the n, so this third does not reach that negative. It was only on the n stuff. So that third and that third actually cancel out, a third root and a third power. So I have a negative on negative n plus 3. See, that negative is still there. And then the root and the power cancel out, so everything that was in there is still there. Okay, now this negative is going to go in there. So I have n minus 3 plus 3, which equals n. So that one worked. So far this is a yes. Okay, then I need g of f of x. It has to work both ways. So here's f of x. It's right here. Negative n to the third plus 3. Okay, I got to stick that into g. So here's g. It's the third root of negative something plus 3. See, that negative is going to go on everything that is n. So that negative is going to everything that is n. So now all of that goes in there. Negative n to the third plus 3. Okay, you got to do order of operations. We got to do the inside first here. So that negative is going to come in there first. So a negative n to the third is positive n to the third. Negative 3 plus 3. It's not time to cancel out the third root yet because this is like implied parentheses. I'm still in the parentheses. Negative 3 plus 3 is 0, so I have the third root of n to the third. Now that 3 and that 3 go away and it equals n. This is a yes. These are inverses. What that is saying is if I take any kind of number and put it right there and get an answer, so how about I just take maybe 2. Okay, f of 2, that's negative 2 to the third plus 3. Okay, that's negative and then 8 plus 3, so that's negative 5. So if I start out with a 2, I get a negative 5. So now if I put a negative 5 in the g, it should get me back the 2. So that's the third root of a negative 5 plus 3. Okay, that's the third root of 5 plus 3 is 8, and sure enough, the third root of 8 is 2, which is what I started with. So 2 became negative 5, and negative 5 went back to 2. That's what it means to be yes. So this one over here was a yes, and I think we got a yes out of this one also, didn't we? Yes, those were inverses. Okay. Now here's a couple more practice. Find the inverse. So we're starting out with y equals x over 5, so the inverse is x equals y over 5. I'll multiply both sides by 5. So we have f inverse is 5x. So there it is. Easy to find. Okay, now it says graph them both. So then graph the function and its inverse. Okay, well let's graph this one. We have y equals 1/5 x plus 0 basically. This is in y equals mx plus b format because there's an invisible 1 there. So the slope is 1/5 starting at 0. So if I start at 0, I go up 1 over 5 or down 1 left 5 and plot that line. Okay, there's that one. This one is just y equals 5x plus 0, means it's starting at 0 with a slope of 5 over 1. So if I plot this one, starts at 0, and then it goes up 5 over 1, 1, 2, 3, 4, 5 over 1, or down 1, 1, 2, or down 5, left 1, 1, 2, 3, 4, 5, 1. So the blue line, the second one, is right here. Now remember what I said. See, in black, this point was at 5, 1. And in blue, this point is 1, 5. Sure enough, the x and the y's are in different spots. And here the blue is at -1, -5. And in black, it's at -5, -1. Sure enough, the x and y's are different. I want to show you the diagonal. The diagonal is at 1, 1, 2, 2, 3, 3, 4, 4. The black line and the blue line should be reflected across this red line. See how they're folded? If you fold this dot directly across, it ends up there. If you fold this dot directly across, it ends up there. And the same for all of them. If I fold this dot directly across, it ends up there, and so on. This dot ends up there. That's what inverses do. They fold across this diagonal. So there's a couple ways to check and see we have it right. The points should be inversed from one another, and then the picture should fold across the diagonal. Let's try that with 11. First of all, let's find the inverse. So I have y equals -9 minus 7x over 3. So the inverse is x equals -9 minus 7y over 3. And now I've got to solve for y. Multiply both sides by 3. So now I've got 3x equals -9 minus 7y. Move the 9 over. So I have 3x plus 9 equals -7y. And divide off the -7. So you could leave it like this. 3x plus 9 over -7 is the inverse. That's fine. That might be a little bit difficult way to think of graphing it. So you can put the -7 with everybody. That's the same thing as -3/7 x minus 9/7 equals y. That's how I might graph it. Up here, I would probably think of this one as negative 9 over 3 would be negative 3, and then negative 7/3 x. So in order to get them started, so this one is going to start at negative 3 and go down 7, right 3. So start at negative 3. So here, the slope is negative 7/3, so down 7, right 3, but that gets me off the grid. So I think I'll go up 7, left 3. Same thing. So 1, 2, 3, 4, 5, 6, 7, 1, 2, 3. So there's the original. The original is in black. Now one thing we could do is just take this point and exchange it. That should work. This point right here is at negative 3, 0. So I know 0, negative 3 should do it. So 0, negative 3 should be one of them. 0, negative 3 should be right there. That should be one of the dots for my blue. And the x is at negative 3, 4. So I know the blue dot should be at 4, negative 3, right there. And I could just connect those two lines. Or we could graph it. We need to start out at negative 7/9 and then go down 3 over 7. See, that looks a little bit more difficult. Well, let's give it a try. Well, I'm going to draw the blue line first because I already know that's got to be it. But now just to make the point, if we started at negative 7/9, okay, that would be negative 1 and 2/9. So negative 1 and 2/9. So I would have started right there. See how that's on the line? Then the slope was down 3 over 7. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. It would have given me that dot, and connect those two dots and we have the same one. So it seemed easier to use the rule that the dots exchange places than it was to actually graph that one. And if you'll notice, the diagonal is right at 1, 1, 2, 2, 3, 3, negative 1, 1, and so on. So the diagonal is going right up through here, and those two things, sure enough, fold on the diagonal. Okay, what about some kind of a shape that's not quite so obvious, like a line, like this one? How are we going to graph this in the first place? I mean, let's just go ahead and try to graph this shape first. What does y equal negative 2x to the third plus 3 even look like? I just switched it around so that was at the beginning. Well, here's the parent, x to the third. So remember the parent goes 0, 0, and then 1, 1, and negative 1, 1, and then 2, 8, and negative 2, negative 8. There's the parent. It's looking something like that. It's going to get shifted up 3, and then this negative 2 has not been captured by the cube, so it really belongs to the y. So what this means is the y's are going to be multiplied by negative half, and they're going to go up 3. That would be one way to do it. Okay, or we could make ourselves a little bit of a table, which I think I will do. Since I know the general shape, I'm going to get a little table and see what's happening here. How about we start with 0? If I stick 0 in there, negative 2 times 0 plus 3 is 3. So 0, 3 is one of them. That's the vertex shifted up 3. What about 1? Remember, it's supposed to go over 1, up 1 from that? But the ups are gonna be half as much, so it's really gonna go over 1, down a half. I think it's gonna be right there. Well, let's test it out and see. Sticking a 1 in there. 1 to the third is 1 times negative 2, so that's negative 2. Negative 2 plus 3 is 1. Over 1, up 1. Oh yeah, I didn't do this right, did I? That actually is the y multiplier. I was wondering why. That's going to be times negative 2. So it was supposed to be over 1, up 1, but it got multiplied by negative 2. So over 1, down 2. And then over 1, up 1 is going to be multiplied by a negative 2 again. So let's just, but I don't have to care about that. How about we just put in the point, negative 1. If I stick a negative 1 in there, negative 1 to the third is negative 1. So I have negative 2 times negative 1 plus 3. So that's 2 plus 3. So this is 5. So negative 1, 1, 2, 3, 4, 5. See, there goes my shape. Over 1 and it went up 2, over 1 and it went down 2. So I could go over 2, it's supposed to go up 8, but it's really going to be doubled, so it'll be up 16. So here comes the original shape. Okay, now remember, the new shape is going to be along the diagonal. The inverse shape is going to graph itself along the diagonal. So even if we don't really know how to graph it, all we have to do is fold this thing across the diagonal. Okay, well, let's get it first of all. So here was the original. So here was the original. It was this one. I'm going to exchange x for y. So where there's a y, I'll put an x. Where there's an x, I'll put a y. Now I got to resolve that for y, so I'm going to move the 3 to the other side. I'm going to divide both sides by 2. And now I'm going to third root both sides. So I'm going to try to get the third root to cancel out. So I'm going to third root that side. So here's our inverse. F inverse is the third root of x minus 3 over 2. So they asked us to find the inverse. Okay, there it is. And now to graph it. Okay, I'm going to use some of the things that I know. That dot right there is at 1, 1. So I'm going to exchange them. Well, when I change places, it's still at 1, 1. So the blue one is still at 1, 1. But this dot is at 0, 3. That means my blue one's going to be at 3, 0. Okay, this dot up here is at negative 1, 5. That means the blue one is going to be at 5, negative 1. Now, can we figure out what any of that is? I don't think I can quite yet, so I'm going to get one more point over here on this table at 2. I'm going to plug a 2 in there. 2 to the third is 8 times negative 2 is negative 16. Negative 16 plus 3 is negative 13. So at 2, it was really down here at negative 13. So the blue one is going to be negative 13, 2. So it's going to be way over here at 13, up 2. Okay, that might help me graph it. I have these 3 points and this one way out here. So it's looking like this. Now with that, can you see how it actually does look like it's mirrored itself across that red diagonal? That's the idea. Okay, I want to show another thing on our calculator that will help. Of course, you have your calculator here. So let's take a look at the y equals thing. I'm going to put in the original one, 3 minus 2x to the third. I'm going to put that one in y1. Okay, I'm going to graph that. There it is, looking just like what we drew. Okay, now I'm going to put in the inverse. The inverse is right here, the third root of x minus 3 over 2. So I'm going to put it in like this. Oops, not there. Let me put that thing back in how it was. What was it? 3 minus 2. Okay, so on the second one, so I want to make sure I go to the second equation, and I'm going to put in, I'm putting it in 2 parentheses because I want x minus 3 as a group to be divided by 2. Then I want all of that to the third power, because a third root is the same as a third power, and then I have to put that in parentheses when on this kind of calculator when it's flat, because I want this to be 1/3 and not just power 1. Okay, I'm going to graph that one. So here comes the original, and now here comes the inverse one that should be sideways of that. See, that's what Ooh, it doesn't quite look the same, does it? Oh, gosh, this was a -2 right there. That should be divided by -2 divided by -2. Let me get that into my calculator right here. That needs to be divided by -2. Now there's the original, and here comes what we have on our paper. See, this thing up here was high, and then it went down low. It was doing it backwards from before. Okay, now, just so I can see on my calculator for equation number 3, I'm going to put the diagonal, which is y equals x. That should help me see that it folds right across there. Now, sometimes it doesn't quite look like it because the calculator's got 4 pixels for every 3 pixels. It's not really a square. Okay, if you go to zoom and see number 5, usually we go to standard and it puts 10 tick marks sideways and 10 tick marks up and down, but sideways is spread out more because it's wider. If you do square, it'll square it up. I'm gonna go down to zoom square just so it looks like it actually folds. See, now it's got a little bit more than 10 going across, so that all the tick marks are the same amount. And now that actually looks like it's folding right across there. Okay, one other thing that I want to take a look at is the table. See here in yellow table, so I'm going to hit yellow table, second table. All right, so let's compare some of these. See right here in my table for the original one was 0, 3, so there's the 0, 3. Here's the second equation. The second equation then would have been 3, 0. So if I go down to the x for 3, see there's the one matching up with it, 3, 0. And also 1, 1 was the original, and then 1, 1 is the same thing when we turn it around. Okay, see there's 1, 1 for the first one, and 1, 1 for the second one. And then -1, 5, there's the -1, 5. 5, -1 should also be on there. See there's 5, -1. Okay, let's do the next one. First, we could graph it. Now, this is to the 5th power. Well, let's get a few of them and see what we can do here. Get to the 5th power. How about we go... I'm going to start out with 0. If I stick a 0 right there, 0 minus 2 is -2. -2 to the 5th. That's 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So if I stick a 0 in there, this gets me -2 to the 5th, which is -32, and then times this 2 in the front. So 0 is at -64. All right. How about we do something that makes it not quite so gigantic? How about 1? If I stick a 1 in there, 1 minus 2, so that's going to become -1 to the 5th times 2. -1 to the 5th is -1, so that's 2 times -1, so that's -2. Okay, great. How about a 2? If I stick a 2 in there, we get 0. 0 to the 5th is still 0, times 2 is still 0. Looks like bigger numbers are keeping it small. If I stick a 3 in there, 3 minus 2 is 1. 1 to the 5th is still 1. 1 times 2 is 2. We could go 4 maybe. If I stick a 4 in there, I get 2. 2 to the 5th is 32. Times 2 is 64. So it got big right from there. So it looks like these 3 dots right in there are going to be the ones I'm going to play with. 0, -64, way down. 1, -2. 2, 0. 3, 2. And then 4 is way up there at 64. So I got 4 is way up there at 64. 0 is way down here at -64. So I have this thing coming through there like that. Okay, so there's the original. Now for the other one, I know that this dot's going to be at negative 2, 1. This one's going to be at 0, 2. This one's going to be at 2, 3. This one's going to be at 64, 4. And this one's at negative 64, 0. Okay, negative 64, 0 is way out here somewhere. I'll just put it way out there. Negative 2, 1. Negative 2, 1 is right there. See, that's the opposite of this one right here. 0, 2. That's the opposite of this one right here. 2, 3. That's the opposite of that one right there. Now, what are those things, what is that going to look like? Maybe I'll go 64, 4. Oh, way out 64, up 4. Like way out here. That sometimes helps to get that last one. So now I can connect that looking like this. And it sure does look now like I got it to go across the diagonal. So this is how you check these visually. Is that splitting itself across the diagonal? And sure enough. Now to check that on our calculator, let me put the first one in, which was 2 times x minus 2 all to the 5th. Okay, that kind of looks like the blue one. Okay, I never did figure out the inverse yet. We better do that. So this is the letter y, so that's going to become the letter x, 2, and then y minus 2 all to the 5th. Now I got to solve it for y. Okay, I'll divide off the 2. Now I got to get the 5th power to cancel out. Well, that's the 5th root. So I'm going to 5th root both sides. So now I have the 5th root of x minus 2 equals y minus 2, and move the 2 to the other side. So the answer for the inverse is f inverse of x is all of this plus 2. So it's the 5th root of x over 2 plus 2 on the outside. So there's the inverse. And the black one, the black one is its graph. Let's put that in the calculator. So I need the 5th root of, so I'm going to take x, I'm going to take the package x divided by 2 to the power 1/5. I'm just going to call it 0.2 since that's easier to put in. That's what 1/5 is. So this piece is to the power 1/5 and then plus 2. So the plus 2 is not under the 1/5 power there. And here comes the other one. Looks almost like what we have. Having some resolution problems. I think I'm going to go back to Zoom 6 so it spreads it out a little bit more. And then there comes the diagonal. Okay, so I just have some practice on these. I just did several of them for practice. Well, let's see what we have to remember back a ways. What does the parent look like? This parent looks like this. That's the 1 over x. It's going to be shifted. It's going to be up 3, and it's going to be left 2. And it's also going to be upside down. So really it's going to not look like this. It's going to be down here, shifted up 3, left 2. So I actually think I might graph it that way this time. So this parent, right, there's no multipliers. That's why I like that. Well, there was, flipping it upside down. So there was the parent. If we flip it upside down, this should be at 1, 1 right there. So 1, 1 should be here, but then that parent is going to go up 3 and left 2. So this 1, 1 is up 3, left 2. Now I'm actually just going to move the 0, 0. The 0, 0 is also going to go up 3, left 2. 1, 2, 3, 1, 2. So really this is the new grid. So see, I've got a dot, this dot here, and then it's just going to go this way. And then I have that dot there, over one, up one from the new center, and it goes this way. That's how accurate we were graphing those back when we were doing parent functions. So that's the graph of this one. Let's see if I can't get a couple of the points so I can switch it around with the inverse. It's going to look weird seeing that thing, so the diagonal of that. Okay, -1, 2 was one of them. And it looks like -3, 4 was another one. So that should work if I stick those in there. If I stick a -1 there. So I have 1 over -1 plus 2 plus 3, with this being negative. So I'm just sticking this -1 in there to confirm that it's 2. Okay, -1 plus 2, so that's -1 over 1 plus 3. Sure enough, that's 2. So I'm going to trust this one works also. Okay, and I think I'll go ahead and look at my calculator in case maybe I can get a couple more. Let me put that one in. It's 1 over x plus 2 all negated, so I'm going to go negative and then put it in. I need another set of parentheses. 1 let's see, not there. 1 divided by the package, x plus 2. That closes the package. That closes the 1 over. And then there's a plus 3. Okay, so sure enough, there's the little, this is right there. And of course, I still have that diagonal in there. And this was the asymptote. This calculator puts in the asymptotes. What I really want is to look at the table. So see, there's the -1, 2, which is this one. I'm going to look for some more clean ones. There's the -3, 4. There are other good ones. It doesn't really look like it going way up there. I don't want to graph out to -32 anyway. Let's go the other way. I think I would like one more dot if I could get it. If I can't get it, can't get it. I would like whole numbers. That's what I'm looking for. Not looking so good. 95, 295. It's getting closer to 3. 296, 297. 290. Come on. Okay. It's not looking so good, is it? So I think we'll just leave it there. So that means for the other dot that we're going to have a 2, 1, 2, -1, and a 4, -3. Okay, also the center right here is at -2, 3. So the center is going to be at 3, -2. 1, 2, 3, 1, 2. So right here's the new center. And now let's plot this dot. 2, -1, 2, -1. See how that's up 1 over 1 from the new center? And 4, -3. 4, 1, 2, 3. That's from that center. So this one's going that way. Now, I'm going to put this on the calculator just so we can see, so that means I'm going to stretch this out a little bit. So the blue one would go way up like that, and it would come way over like that. Similarly here, this one would be coming down and over. And then the black one would be coming like this. Now see, this black one, if it gets folded, it lands on the blue gets folded, it lands there, and you can kind of see this one mirroring itself. So if I take my diagonal and put it through there, it's reasonably easy to see that this part does that. Okay, can I graph this? Oh, I haven't found it yet. So let's find what the blue is. Okay, right there's y. I'll put that in as an x. Negative 1 over y plus 2 plus 3. Let's resolve that for y. Move the 3 over. Okay, now's the trick I was going to use earlier. When y is on the bottom and you got to cross multiply to get it out of there and all that, you could just flip the whole thing over. This is the same, remember, we're going to cross multiply. It's going to be these two are ended up multiplying and the ones are ended up multiplying. Well, nothing changes if I flip it over. See how nothing changed? All I have to do now is multiply both sides by -1 and that cancels out. It's just going to put the negative over there. So I've got y plus 2 equals all of that and subtract the 2. So I've got -1 over x minus 3 subtract the 2, and there's the new inverse. I'm just going to put a prime on there this time so I can indicate this is the inverse. So this should be the graph of the blue. Okay, well let's see. Okay, so I need -1 over x minus 3. So I need -1 over x minus 3. So there's the first fraction, -1 over x minus 3, and then minus 2. And there's the calculator's best version of this picture. Okay, one more. Those seem to be a little bit difficult. All right, so here's our parent again, y equals 1 over x. So I know that it's going to be at 1, 1, 1, and -1, -1. So usually it's in quadrants 1 and 3 from the parents from a while back. Okay, so this means it's going to go down 2. This means it's going to go right 1. And this means it's going to be times 3 tall. So the y's are going to be 3 times as tall. So really, instead of over 1 up 1, it's going to be over 1 up 3. Okay, well, let's get it shifted first. So the real center. We'll do the original first. So 0, 0 is going to get shifted down 2, right 1. So right there's that. So here is the new axis. Okay, it's supposed to be at 1, 1, but it's 3 times taller, so it's going to be at 1, 1, 2, 3. So there's a real dot. And it's supposed to be at -1, -1, but it's going to be 3 times taller, so 1, 2, 3. All right, so it's going to come up into that one, and eventually come down into that asymptote, and this one's going to come into that asymptote, and down to that one. So there we have it graphed. Some good practice from a long time ago. Okay, this center was at 1, -2. That means the other center is at -2, 1. So the other asymptotes are going to be over here. Now we can just do what we know. It's going to be over 1 up 3 because it's 3 times taller. It's already been shifted. So over 1 up 3 is going to be 1, 2, 3 right there. That would be one way to do it. Or this dot right here is at 2, 1. So one of the dots is going to go to 1, 2. So the black dot is at 2, 1. So one of the dots on the blue is going to be at 1, 2. This black dot down here is at, what was this one at? 0, -5. So the blue dot is going to be at -5, 0. Okay, this dot's not in there. Okay, so let's see. So here's the 1, 1, and there's the other one. Let's bring this one into and up to there. And that puts this one into the blue asymptote and up to there. So there's our graph. Does it at all look like this? Does it go across the diagonal? And sure enough, the blue and this black is going to where that blue is. This black is going to where that blue is, and likewise over here. So if I want to find that equation where this y is, I'm going to put an x. 3 over where that x is, I'm going to put a y. Move the 2. Okay, turn them upside down. Multiply by 3. So I have 3 over x plus 2. And add 1. So here's our new f prime. It's 3 over x plus 2, add 1. And there's the blue graph of that. Okay, those are inverses. Try some of those.